There is a very fascinating mystery about galaxies that puzzled astronomers for a very long time. For decades, astronomers have been observing and cataloging galaxies in the universe, classifying them by their sizes and shapes. Many galaxies appear beautiful and orderly, graceful spirals and smooth elliptical systems. But others look completely different, distorted, chaotic, and quite frankly, messed up. These are what we call irregular galaxies. This raised an important question. How does a galaxy become irregular? What could possibly twist and distort an entire galaxy? For a long time, nobody knew the answer until we realized something extraordinary. Galaxies collide. Galaxies feel each other's gravity. Over billions of years, they are drawn together and eventually collide. The result is a cosmic train wreck, a spectacular event that can tear galaxies apart, fling stars across the space, and completely transform galaxies' shape and structure. But how do we know galaxies actually collide? Much of the understanding about galaxy collision comes from computer simulations. We place virtual galaxies and their gravity forces inside a computer, run the simulation, and then watch billions of years unfold in just a few minutes. Remarkably, these simulations produce the same features that we observe in the real universe: tidal tails, bridges between galaxies, and highly distorted shapes. In other words, by simulating gravity on a computer, we can recreate the very cosmic havoc we see across the universe. But does this cosmic havoc lead to complete destruction of galaxies, or to the creation of something new? Ironically, a galaxy collision does not usually lead to the destruction and death of galaxies. In fact, it often does the exact opposite. It triggers the formation of new stars. In that sense, galaxy collisions are one of the key drivers of galactic evolution. But this leads to an important question. How can galaxies collide without simply destroying everything inside them? To understand this, it helps to think about what a galaxy really is. A galaxy may contain hundreds of billions of stars, but those stars are separated by enormous distances. Take our own Milky Way. We live near the edge of a small spiral arm called the Orion Spur. Even though our stellar neighborhood appears crowded, the nearest star system, Alpha Centauri, is still about 4.3 light years away. So while galaxies may contain vast number of stars, the space between individual stars is enormous. As a result, when two galaxies collide, the chance of one star directly hitting other is extremely small. But that does not mean that nothing happens, because galaxies are not empty between the stars. The space between stars is filled with vast reservoirs of gas and dust. Within this material are dense regions known as molecular clouds, the birthplaces of new stars. When galaxies collide, these gas clouds interact strongly. Gas is compressed, flows are disrupted, and powerful shock waves are generated. Material can be stripped from one galaxy and pulled into another. Huge streams of gas can be pulled across intergalactic space by gravity. This triggers the formation of new molecular clouds, and existing ones collapse more rapidly, triggering intense bursts of star formation. So a galaxy collision is not merely an act of destruction. It is also an act of creation. It reshapes galaxies, redistributes their gas, and ignites the birth of countless new stars. Now you may ask, are galaxy collisions just distant phenomena, or do they happen closer to our home as well? Right now, our home galaxy, the Milky Way, is undergoing a collision with another galaxy. This intruder is a relatively small galaxy called the Sagittarius Dwarf Galaxy. Sagittarius has passed through the Milky Way multiple times over the past several billion years and is now being gradually torn apart by tidal forces. Interestingly, these passages coincides with the increased star formation in the Milky Way itself. Combining observational data with computer simulations, astronomers found 3 periods of increased star formation in the Milky Way. These periods peaked around 6 billion years ago, 2 billion years ago, and 1 billion years ago, corresponding with the time when Sagittarius is believed to have passed through the disk of the Milky Way galaxy. Aside from generating new pockets of star formation, galaxy interactions can dramatically reshape structure. They can create long tidal tails, generate rings and shells, and create ripples. In fact, observations from the Gaia mission show that the Milky Way's disk is slightly warped and wobbling, likely influenced in the past by interactions with the galaxy merger. Another striking example is the Tadpole Galaxy, located about 420 million light-years away. The most interesting feature of this galaxy is a star trail extending 280,000 light-years. There is evidence that about 100 million years ago, a compact intruder galaxy passed close to it. During this encounter, gravitational forces disrupted the star's gas and dust in the galaxy, creating the dramatic tail we observe today. These subtle distortions are signatures of long and active dynamical history. It is a direct snapshot of a galaxy in transformation. So the next time you see an irregular galaxy with twisted arms or chaotic appearance, remember, you may be witnessing the aftermath of a cosmic collision, and what appears to be a chaos is actually a transformation. In the universe, collisions are not merely acts of destruction, they are also acts of creation.